This is section 1.6. It's on naming polygons. This all should be reviewed. We're going to recall that a polygon is a closed figure in a plane formed by segments called sides. So those segments touch each other. That's what makes it closed. And these shapes are two-dimensional. That's why we say they're in a plane. A polygon is named by the number of its sides or angles. So we use prefixes to give the name of the polygon. So for example, 3 sides is a triangle. 4 sides is a quadrilateral. There's lots of different types of quadrilaterals. We'll talk about that later. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. We need to be aware of those names, those 8 names. Now, there are polygons with 11 sides, and there is a specific name, but that's a little too much for you guys to remember. Pretty sure it's called a hendecagon, but what we're going to do just to make it simpler on you is call it an 11gon. A 12-sided figure we'll call a 12gon, so on and so forth. But there is a prefix for each type of polygon, no matter how many sides there are. Obviously, it gets complicated and it's a lot to remember. So we're just going to remember these 8. And you can refer back to this slide anytime you want. Here's an example of a polygon. You can count the sides. It's the same as the number of vertices. That's where the sides come together. Okay, so vertex is the singular form for vertices. There are 6 of them. So this is a hexagon. So 6 different points where the segments come together. Those are each of them are a vertex, or you can call them vertices. Consecutive vertices are those points that have a segment in common. So for example, segment QR is one of the sides of this hexagon. So point Q and point R are consecutive vertices. Sides that are consecutive look like these light green sides. These are sides that share a vertex. So notice how segment RS and segment TS both come together at point S. Those are consecutive sides. They have a point in common. Diagonals are segments that are going to connect your non-consecutive vertices. Look at point P and look at point T. They don't come together to make a side of this hexagon, but you could connect them, and that would be called a diagonal of the shape. There's going to be lots of questions in this section about these terms. So if you ever get confused, you can come right back here, take a look at those. We'll try some now on our own. Actually, we'll do this first. You can classify polygons other ways as well, depending on what their sides and angles look like. Here's an example of an equilateral polygon. What makes it equilateral is all of the sides are the same length. So I'm going to put matching marks here. That indicates that all sides have the same length. That's what equilateral means. Equiangular would mean that all of the angles are the same. And if you look at this shape, that is definitely not the case. This angle down here is acute. This angle up here is obtuse. They can't be the same. So it's automatically not equiangular. This could be a rhombus. Rhombuses have 4 congruent sides, and the angles are not all the same. Here's an example of a shape that is going to be equiangular, but it's not equilateral. So clearly this side is way shorter than this side. It's not equilateral. But if you look at the angle measures, they're all obtuse. And I tried my best to make them all look like they're the same measure. So this type of shape does exist. All the angles are the same, but the side lengths are not all the same. Well, what happens if it's both equilateral and equiangular? That happens as well. When that happens, we're going to call the shape regular. So this is an example of a regular polygon. Here's an example. We're going to name this polygon, and we're going to name it by its vertices. A, B, C, D, E, F. We name them using consecutive vertices. So this is an acceptable name for this polygon. This polygon is a hexagon because there's 6 sides, 6 vertices, so on and so forth. Now, if you wanted to, you could have named this using a different arrangement of these letters. You could have named it starting at A, going this direction. Or you could have started at E and went this direction. You can start at any letter you want. You can go in either direction, but what you can't do is start at point D and jump across the shape. You have to name the figure with its consecutive vertices. So I can look at this name and I know that point C is consecutive with point D. I know that point F is consecutive with point A, just by looking at the name, not the picture. By appearance, would you say this polygon is regular? It sure looks like the sides are the same length, and it looks like the angles are the same measure too. So I'm going to say by appearance, yes, it looks regular. Next question asks you to name 2 consecutive vertices on the polygon. You can look at the picture, or you can look at the name of the shape. I'm going to say that point E and point F are consecutive vertices. I'm going to use a comma here because I'm talking about 2 different points using 1 letter at a time. That is clearly not the only answer, but that one works. Next one asks you to name 2 diagonals on the polygon. And I'll draw some in. There's one of them. That's segment AD. Remember, diagonals are segments. Use 2 letters. Put the segment over top with no arrowheads. Here's another one. Segment BD. Use 2 letters, no arrowheads over top.